Welcome back, everyone. We're doing another quick tip today. I'm with James, another MVP of the Microsoft space around Power BI, and we are getting a bit more deeper into Semantic Link Labs. Semantic Link Labs. I'll try that again. James, welcome.
Thanks, Mike. Good to be here.
All right, today we're going to jump in. We're going to do a little bit of DBA work, I guess, to some degree. We're going to play with some SQL, and we're going to play with SQL inside a Python notebook that is using Semantic Link Labs. Again, we want to make very clear we're not using a Spark notebook in this example, so we're doing a lot of Python-based things. So you'll notice this will look a little bit different than PySpark. Our Spark SQL in the syntax and the language here. But just to be very clear, Semantic Link Labs works in both scenarios. So we're just trying to make sure we explain how the Python side of things and notebooks works. With that being said, James,
the fact is that it can be used in both ways. There's a lot of things that it's like, okay, well, you do this in PySpark, you can only do that in PySpark. With Semantic Link Labs, if you learn how to do it in one, you can do it in both. So
correct, and the syntax is the same.
Yep. All right.
Awesome.
Why don't we go ahead and get started here? So as we've done in many of these videos before, the first thing you got to do in a notebook is pip install the Semantic Link Labs. We're not going to spend too much time talking about that. Wait for that to run here. And then we're also going to need to import the library here. So you import Senpai Labs as labs, and we're going to declare the names of our lakehouse and the workspaces where the workspace where they're stored, lakehouse and the warehouse and where they're stored. So let's see, output is hidden. Okay, so go ahead and give this a run here. Okay, looks like it's done. All right, so now we're gonna run a SQL query or queries against the Fabric warehouse. So this is we're gonna use the connect warehouse function within Labs, and we're going to call the warehouse. You basically just give it the name of the warehouse and the name of the workspace where it is, and we're just gonna say, all right, select the top 100 from the trip. We're using the New York taxi data set, I believe, right, Mike? We'll go ahead and do that here.
So also some prep things that we've done as well. And so James, you may want to show this as well. James has also created a Semantic Link Labs data warehouse. So what we're pulling from here is one thing I just want to kind of call out here. You notice here on the left-hand side in the Explorer window, notice how we have no data items added. There's nothing from a lakehouse. There's no data warehouses attached. So because of that, Semantic Link Labs is securely connecting back to the items in Fabric, and it's using James's credentials here to make sure that he can run these SQL queries back against that engine. So the reason we're using this in this pattern is, you notice at the top there at our notebook, we had a couple variables that we set up by just setting them, right? Here's the lakehouse name, here's the warehouse name. The reason we like to do this is because when you're using dev, test, and prod, sometimes you'll have a cell that needs to set your parameters. If this notebook was moving between different environments, you could fully imagine that the warehouse name might be the same, but the definition of where that warehouse lives in each workspace might be slightly different. So by doing it this way, we're not hard coding a GUID, an attached warehouse directly to this notebook. And this actually gives us the ability to move between environments. And James also here is highlighting by clicking the ellipsis and then going down to that cell's information. If you make this cell a parameterized cell, it will allow you to use these parameters inside a pipeline. So these will be exposed to you at the pipeline level as well. So again, hyper-parameterization, thinking about how do we reuse this notebook if we need to. That's why we're doing it this way. And you'll see later on as we write these SQL statements, James will point you out and show you the warehouse and see where the tables come from. So yes, we are using the New York taxi data, and that data does live in a warehouse.
We can actually see that over here. This is the this is the warehouse. We're actually pulling from the it would be in here, right? If I'm not mistaken.
In DBO, open up DBO. I think there's our tables.
Come on, there we go. Yeah, so there's our tables there. New York taxi data set, right? All right, so we'll go back.
Yep.
And all right, so yeah, we've got the top 100 rows from trip, and there's our all of our values we expect to see there. Okay, cool.
So let's call out a couple of things in this SQL query. Let's just kind of walk through this a little bit. So just notice here that when the statement here is on line 1, I just want to call out a little bit of difference here. Like notice there's this with command. The with command is like opening up a connection. So this is a little bit different than what you may have seen in other functions coming out of Semantic Link Labs. When I need to make a connection, open up a connection to something, the with function opens the connection. you send in the warehouse name and the workspace name. There's some optionals there as well. So if you don't send in the workspace name, it assumes it's in the same workspace that you're in is. But then while that connection is open, you run this as SQL. So the as SQL is saying that's the connection item that I'm going to use to run my query. And then the SQL open connection has a thing called query. And so what we're shoving into this is, okay, we're going to select the top 100 items from the trip table. So all of this is basically denoting for us, where does that table come from? How do I open the connection? And then what we're doing at the end of this function is we're displaying the table. Now, the with connections lab, once that connection is complete, my understanding is it will also automatically close the connection for you after this is run. The sequence of things you need to do is open connection, run the query, close connection. And so all being handled automatically in the notebook for you. And that way it doesn't accidentally run you out of connections on a warehouse, because a connection, warehouse has a limited number of connections, and you only want to have the connection open long enough to actually run that statement. So again, I just want to be clear about why you're seeing this different syntax here with labs.connect warehouse. It's going to be slightly unique.
Cool. No,
okay, sorry,
that
James,
makes sense. I'm glad you brought that up. Cool. So yeah, we got this preview of the data there, and now we're going to come down here and say, well, check this out. What if you had a more complicated? Because this is a pretty simple query, right? Almost nothing to it.
I
Right.
can
Yeah.
read it. Yep.
So
One
right.
liner,
But
no
what if we
big
wanted
deal.
to add something a little more complicated than we have the multi-lines, that kind of thing. So this is kind of neat. We can actually add up multi-lines here. And this is, like for instance, this part here, this could even be on its own order by, and that could be on its own line like
Perfect.
so. All right, that is what we would expect to
Now
see normally in a SQL query if it's done well. And why don't we go ahead and run that? So
now, while James is running this one, I'll just point out the magic sauce of this one is those triple quotes. That triple quote is very important.
That's what allows you to do a multi-line. And actually, in Python, a triple quote like this also allows you to do a block comment, or sometimes people will call it a doc block, where it's like you're documenting a function and you want to have like basically a whole paragraph that describes what that function does right after your the function opens, and you've got all your parameter declarations and type hints and stuff like that. Then you can put this right under that and say, all right, here's what the function does, step by step, bullet points, that kind of thing, and then you don't have to have a bunch of individual comment lines. Everything within those triple quotes will not run as code unless it happens to be inside something that says, actually, this is code. Go ahead and run it. So there we are, and there's exactly the results we would expect to see. So it's aggregated. Cool. All right. Well, now let's go a little bit further and say, all right, well, we could actually take this, even further. And all right, here's a nice, this is almost getting to the point where this is the kind of analytical query we might expect to see when we're doing some ad hoc data exploration and trying to figure out, is there, can we make a report out of this, right? All right, so let's take a look and see what we get here.
So we're doing some joins. We've got like our main trip table as our starting point. We're doing like a left join on the date. We're adding some geography things. And now that we've added the geography, we can then group by those geographical things because we're doing those joins again. So again, normal SQL run just like everything else. The only downside of this is you don't get the pretty formatting of this SQL statement. It doesn't colorize it for you. But now there we go. So now we've got our grouping by those different data elements, or there's other data elements here in our table as well. So again, runs just like normal SQL.
Pretty neat. All right. And now, of course, as we talked about earlier, it's possible to parameterize basically almost anything in these notebooks. And so within these, this is a string, and within a Python, you can inject variables into a string, so that when whatever the value of that variable happens to be at the time when you run it, it substitutes that variable value into that slot. So here's something really interesting you can do. We're going to modify that query up there, and we're actually going to add some parameterization to it here. So the pickup hour, we're going to say it starts at 7 a.m. and it goes till 6 p.m. And then right now we're going to say, I'm not going to include the county or the city level. And what I've done down here is basically I've done this conditionally, where if include county is there, it's going to include the county column, and then of course down here in the grouping it has to do that as well. But if it doesn't, so if that's false, it's going to say, well, we want to return this the comment, what normally when you're writing SQL, you put a double dash before it, it says, all right, don't include that for now. So this is conditionally adding or removing those columns from the select statement. So why don't we go ahead and run it as it is now?
Mm-hmm. A couple of things about this. Okay, there's a huge debate in the area. We're going to make a lot of people angry with this comment. I'm just going to throw it out there. I'll let you know. So we'll explain a bit more of the code here in just a second. But notice in this code, we are writing all of these statements with the comma in the front of the line. Okay, so I just want to be clear about this one. The reason why we're putting the commas at the front is because it makes it very easy for us to add a single if statement. So what this is doing, the braces, and this is kind of how you read this, right? So there's two things that change between the last code block and this code block. The first change, yeah, that's the major change we can see here. But if you look at line 16, and there's a little F
I forgot
symbol.
to mention that.
So this is important, because if you don't put the F at the beginning of the SQL statement, I can't insert parameters or an option to do something inside here. So what's actually happening is James made this very elegant include county, include city as just a flag. And so what we do is we escape out of the text block, basically, and anywhere we see the brace at the beginning and the brace at the end, that now says, okay, we're going to run some other logic. This is going to be outside of that text statement, and the result of that is either nothing, the blank blank that you have in the beginning. So blank blank, if include country is something, then we're going to include the else.
Yep.
So that's what adds the commenting. So it's basically a conditional say, comment it out or not. And so that's a very elegant way. And the reason we like this is because in SQL, we have to be very explicit about what we're grouping by. So in this example, the country and the city are both grouping columns that need to be included in the group by statement at the bottom. Well, this is very handy now, because now I have a single thing, say include the country, include the city. And now in two places in my SQL code, I can add the appropriate code for both items, both statements.
Yep.
So again, I'm going to be very clear here. I'm a big proponent of use the comma at the front of the line. This is just a great reinforcing statement as to why I may want to use that. So I find it's very easy to write SQL when I put the commas at the front. Others and more hardcore SQL developers, I know Seth Bauer adamantly disagrees with me about this, but that's okay. I'm allowing some people to have disagreements here, but I think this is very cool and useful. And in this case, we are leveraging the comma in the front to make our code work very clean here. If you had the commas at the back end of the items, you would notice line 36 and 37. If we were going to try to not use them, it makes it much more difficult to add the code that you would need, because those commas need to be removed in the SQL statement. So again, that's why we're leveraging this comma in the front mentality to increase this as well. You're also going to explain that one other too, James. I think you're going to put your finger near the pickup hour and pickup hour end. Can you explain that little line of code there in line 33?
What's going on here is we're modifying the where clause. So in the New York Taxi data set, there is the time of day where the fare was picked up by the taxi. And so the pickup hour start, this is basically saying, all right, what time of day do I want to begin considering? Like, do I want the results to say? So if they were picked up between the hours of X and Y, right? So this can change. I can say, well, I want to find out if the rider was picked up between, like, in basically this is business hours essentially, right? So 7 a.m. to 6 p.m. roughly. Well, what if I want to know if they were picked up during like last call in New York City? That's usually
Happy
like
hour.
1 to 4 a.m. depending on the bar.
Yeah, sure.
Right. Right.
Yeah, exactly right.
That's what you can do here really easily. I can say, actually, I'm going to go here. I'm going to comment that out, bring that in, and I'm going to run it again. And that just right there completely replaces the 7 and the 18 here and here with 1 and 4. Immediately changes it from business hours to last call hours, and the results are different as a result.
Now, another thing I want to call out here that James is doing that's very well written here, and again, I really want to give James mad credit for writing really good Python here. notice how he's using the pickup hour as the object that's storing these two pieces. So the pickup hour has object called start equals 1, end equals 4. So this is a complex object. So that way I can use the same variable, essentially, the thing called pickup hour. And the syntax down below is, notice how pickup hour is using the brackets next to it. So pickup hour, the object named start, that's the value that will be returned. So that's why it's returning the 1. And then on the end side, you'll notice it's picking up the 4 on the other side of it. So that's why we're doing this. And it's just, again, brilliant code, very well written here. I really like how the clean this looks. And it's very easy to read because I can say, oh, when the pickup hour is start and when the pickup hour is end, I very intuitively know what that's doing in the time. So that just reading the code, looking at it, I mean, I not everyone would agree with me here, but I say the code is the documentation to some degree. So make it understandable for the person behind you to read and understand the code.
To a certain extent, yeah. Like if you do a good job of naming your variables, and you use something like, in this case, this object type, this is called a dictionary. And what we're doing here is we're going to the dictionary, and this is the key, and this is the value. So they're called key value pairs. Within a dictionary, you have your key and your value, your key and your value. So if I wanted to, I could actually say pickup hour dot keys, and that would give me start and end as a list. I could say pickup hour dot values, and that would give you 1 and 4 as a list. So fun things you can do with dictionaries that are, it's I think it's a little more flexible than just declaring everything as a scalar value.
Totally would agree. Love it. Awesome. What else you got for us, James?
Yeah, why don't we go ahead and, so right now we're seeing, okay, so we have state, then there's a total fair amount, total trip distance, right? So these are the aggregation columns that we were expecting to see no matter what, right?
Yeah, we want more grouping.
So right now we only have state. What if I want to add county? Let's add like an additional granularity level here. Let's going to go true here, and we're going to play that now.
This is so cool. I love this. This is so neat. Great example. I love it. Look at that. Boom. SQL query just changes dynamically.
Got a brand new column, and then the granularity recomputes at that. Here's another cool pattern that I learned how to do recently. If you want to be able to turn something, oops, I didn't mean to do that. I didn't want to run it. I just wanted to give myself a new line. This is the problem with having DAX brain and Python brain in the same brain, because you shift enter. Check this out.
In the wrong place.
So you can have one commented out and the other one ready to go. So like when you need to switch back and forth between them, I'm saying, all right, cool. Well, this one was false. I'm going to comment that out, turn it true, run it.
Ta-da.
Now we get city.
Look at that. Love it. Super cool. So again, this is an example here of like how you can really parameterize. And another thing I'll really quickly call out here is we put these variables that you're using here for include county, including city, they're inside this single cell. But what we talked about earlier was you could move these parameters. These could be your controls that you put at the parameterized cell up at the top of your notebook.
Just as easily
so again,
up here with the rest of these things.
Right up at the top. Block. Yep. So what that does is, again, it adds another hook between this SQL query upstream into the pipelines. And so now I can run a pipeline that acknowledges these parameters, and then I can shove in the values that I want. And so the pipeline can do, like, let's imagine you need to run a SQL query multiple times and aggregate different data, or go different time ranges, or you're doing everything every hour. I need to loop through 12 hours. This will let you do that now. You can now make a looping experience in the pipeline that will go get or do something with a regularly running time window of data. So this is why we're doing this, is because all of this can now be pushed upstream and be controlled at the pipeline level, which is super amazing.
Like you could go wild with this. You could say, you could parameterize every column name, parameterize every table name, and you could even go, okay, well, if your tables are named and you have your primary key and foreign key columns named as the name of the table plus key or ID, you could parameterize that and this and geography and geography. You could go wild with this and make it so like, okay, I'm going to run this notebook 5 times. Each time I'm going to pass it a whole different set of parameters. I'm going to give it the names of the tables I want to select from, the columns I want to select on, what I want it to aggregate on, and just have essentially this whole thing could be parameterized from top to bottom.
It's very cool. So anyways, I don't know where you would exactly use all of that yet. I mean, you'll probably have your own use cases, but I just want to show you that this is the art of the possible.
If you wanted to send a static report out to people, it's like, okay, I want to send these separate, reports, and I want to be able to run just a single notebook that I have it loop through a few times and send different results of data to say different people. You could parameterize the recipients list too. So pretty neat stuff. Cool.
Love it.
All right. Well, let's continue here. So we're going back to something a little simpler now. We're going to actually look and see what tables are available in a warehouse. This is kind of a nice utility when you're like, okay, well, I don't have a list over here because what's the point? If I'm adding it here, it's not going to help me because these things don't actually access the tables through the Explorer. They access them through the APIs in the back end. So because I don't add them here, I would sometimes be able to need to be able to see what tables I have available to select from. So I'll go ahead and run this, and then that will tell me here are the tables available to you. Here's the schema, the table name, and the table type. Cool. And then what if we want to get a little further beyond that and say, all right, what are the columns that are available in each table, going down into a deeper granularity level here. There we go. All right, so now we have here's the date table, and you get these things where it says, all right, well this table's longer than what we can show in this little window here. So we're giving you a little, here's the beginning and here's the end of that result set. But yeah, there you go. Here's the table, the column name, the data type, whether that column is nullable, and the character max length. The kind of stuff you would expect to see if you were looking at it in, say, SSMS.
Now, another thing here too, James, you're showing in this example here, we're doing column list. We're just kind of calling out the name. So the first line one is saying, go get the data stored in this variable called column list. The second item in this list is saying display it. But if we do a display, so we wrap that column list in a function called display, this should allow us to be able to show you this in a filterable table. It kind of this is a notebook experience of Fabric, where it will now give you a prettier view of the table, and now you actually have column level filtering, and you can
over here,
get the ellipsis, data statistics on what's going on in the columns, a whole bunch of other things. So search for things. Perfect.
Cool stuff.
Yep. So that's how you change this experience. So what we were just doing was the standard print what the data was there, and now we're showing you this is the Fabric way of doing a display function here as well. Let's put a pie chart. Yes, James. We so endorse pie charts. Hide that. Don't let anyone see we're doing pie charts.
All right. Awesome. Cool. So what if we wanted to get it obviously there's a way we could add filters to this using the UI, but what if I don't want to go through that hassle and I already know the table I want to see? I'll just add a little filter here. So give me the column list, and then we're actually going to add this filter here that says the table name has to be time, and that's what we can we'll look at now. Oh yeah, there we go. There's our shortened list, and that's what we're looking for.
Filtered list.
Cool. All right.
This is something I always forget. I always forget how to do filtering on stuff. I always forget I had to go grab the data frame, then I had to call off the data frame column name, and then double equal. So I always try to show those as examples so I can remember how to do it.
Yep.
All right.
So we earlier we did pulling data out of a data warehouse, but as people who've been working with the data warehouse in Fabric know, you can't modify a Fabric warehouse using normally using the your standard PySpark notebook, because it's not supported. It's not a data lakehouse, so Spark doesn't work with it. But guess what does? Semantic Link Labs works with it, so you can run your queries here, and you can say, all right, the same SQL statements that you would normally run in SSMS or however you're normally going to go and create a schema, create a table, things like that. You can just throw those queries in here and create schema. And I'm actually going to do that. I'm going to come over here and show you in the warehouse.
Yeah, and for context, a schema is this you can think of a schema as a database, right? So in the SQL world of things, my mind goes to, I have a server, and then on that server I have databases, and then inside the databases I have tables. So that's kind of my mental model here. And what James is doing is he ran the SQL command to create a new schema. And then what that does over here is it then builds a brand new schema in the warehouse for us automatically. And so now we can create that here. So we can actually start building artifacts, creating new elements directly in the warehouse and start shoving in data. So that's really neat there. And the next command here behind this one is, okay, we did it to create one item, but because of this SQL query object, it actually allows you to run multiple queries at once. So what this does is it will allow you to make an array of queries and then pass each query in. And then while the connection's open, it will run multiple SQL queries at the same time and produce multiple results. So yeah, so we can run this now and make 2 more schemas.
Guess what? You could parameterize that too if you wanted to. you could make those dynamic if you wanted as well. Now, if you don't have things to put in there, having the F on there is not going to change anything. So, yep. So I'll go ahead and run that.
Yep.
And we'll go back over here and
so there you go.
Again, and we should see now that we've got a. We should now see the silver and gold show up.
And you'll notice here too as well, James is clicking on the ellipsis up there. So this doesn't automatically give you the schema by default. When you do this, you'll have to go up there and click the ellipsis, and then silver and gold, those tables then automatically show up in this list. So that's how you would do that, and you'd build those tables dynamically here, all of that as well.
Cool. Well, what if we're like, you know what? No, I want to destroy all of that stuff that I just made. You can turn right around and drop them too.
You can totally do that. Yeah, and then again, we're still utilizing the idea here that we can have multiple SQL queries all stuck together in the same object here. Again, making this more efficient. You may need, again, this is the example here is it's doing some command, is running these commands in multiple times. So this is keeping the same connection open for every single item in this list, which is kind of fun.
And like if you want to make it a little easier to read, you can also do something like this.
Exactly right. And now you've got an object list.
Is it maybe because I modified it while it was running? Oops. So yeah, like you can do that, and now you've got, it's a little easier to read. You can also do, like, this is another thing that's nice about Python. You can add a comma on every line, and it's not going to break anything. So now you can comment, uncomment any line you want, and it won't break. So yeah.
Awesome.
Anyway, we'll go ahead and move on here. So this is to run a SQL query or queries against a Fabric lakehouse. Same exact pattern, but we could do it with a lakehouse rather than a warehouse. So go ahead and run that. When these are
so this is another key difference. We're using a new function. So this is the new connect lakehouse, and I'll get that function here from the Semantic Link Labs as well. This is really useful. Again, now it doesn't matter. I'm writing a very similar statement, still SQL, still running against a different engine. It's now grabbing the data that we have in a different place. So again, if you are a SQL DBA, if you have SQL knowledge, you can just re-leverage that knowledge. And so all you need to learn is 3 lines of code, actually only 2 lines of code, and then all of your existing SQL knowledge still applies. And so this is why I really think like using notebooks, using Python, it really isn't that big of a deal for SQL DBAs. You're already doing create tables. You're already writing complex store procedures, right? You already understand how programming things works. All you need to do here in Python is learn a little bit of syntax, and then all of your SQL knowledge can be reapplied here as well.
Like save this stuff in a template notebook, and then every time you want to make a new thing, you just make a copy of that template notebook, come in here and go in and just start cloning that cell however many times you need it, and then paste in whatever query you need in the SQL there. Yep. So this is a table we had from a previous live stream we did where we were doing dimbar and fact foo, and so there's our dimension rows, and then we can do the same thing down here where we're looking at, we're going to multiple. Of course, we can do multiple. So we're selecting all of the everything from dimbar, and we can also select distinct the dimension ID from fact foo and get all of them together. So let's go ahead and do that.
Again, leveraging those 2 SQL queries at the same time. Now we have 2 data puts. So now the data frame, right? So that data frame we had there is a group of data frames. We have multiple data frames in that object, and so again, you now have a single element that you can then loop through and get all the data out. So again, it makes it very efficient to go get data from these different spaces, and that's basically it.
I was going to say one of the things. All of our main things. DFS, right? So that's the plural, right? We should mention that. So this returns multiple data frames, and it gets stored in this here, and then for DF and DFS, we're essentially looping through that and then doing a display for each one. But you can also reference a specific one if you wanted to. You could come down here and do DFS 0. That would give you the first one. So you do display like. Whoop. one
Oh, I like that. Yeah,
like
exactly
that,
right.
and that will give us just the first one. There you go.
Boom. And
Yep.
then you can switch it
Yep.
to a number one, and
Yep,
that will give you the
exactly.
second one.
So
Easy. All right, with that, I think we're
so.
done. That's all the only things we wanted to show you here. A kind of a deep dive on how to run SQL against your warehouse and against your lakehouse. This is all done in the Python notebook. So this is a single node cluster. It is in a Python notebook. This is not using PySpark. Again, very efficient for doing like lightweight exercises, lightweight activities. You don't need multi-threading here. You're doing everything on one single machine. And that's kind of the idea.
It's powerful enough to do
With
a
that,
lot. I mean,
thank
you can get I mean the size of data that it takes to get to where PySpark is the more efficient is a lot bigger than what you might expect. Cool.
Excellent. All right. With that, I say thank you all so much. We appreciate you listening and watching our episode today. Hope you have learned something good here. If you found this to be useful, please share it with somebody else. Let them know that you found this to be good, useful information. We appreciate the link and the share. And we'll see you next time for another quick tip around Semantic Link Labs.
Thank you, everyone. Take care.